Hi and welcome to our chapter 3 video. We are Isaac and Gustavo, and this is about network protocols and communications. First, networks are everywhere. They are from chat sessions that are Messenger, WhatsApp. There are online debates in school, as we all have had before, I think. Discussion boards. We have also used that in many classes. And development framework is used to maintain and understand network platforms. This means that we need to be understand and we have to understand the other part. So a framework is what helps in this communication process for we to be understand and for us to understand the other part. The communication is composed of a message, uh, source or sender. This means that it can be a person or it can be a computer, whatever is the thing that wants to transmit something. The thing that this something wants to transmit is called the message, and this message should be understandable, and it should go in. It should be sent in a channel or media. This can be air. This can be copper cables, or I don't know. This can be anything you can communicate. This can even be light, you know. And finally is the destination or receiver, which is the thing or the person that will simulate your message. This whole process of communication uh, is governed by some rules that they are called protocols. Uh, Protocols are necessary for the communication to be uh, understand in both parts, as sender and as a receiver. There are some requirements for communication. We can analyze the human communication, and first you need to identify the sender and the receiver. If one of these is missing, there's no communication. It cannot be possible, because someone needs to be understand and someone needs to understand. Uh, they also have to have a common language and grammar, because there can be some flaws in communication, some information losses if there is not a common agreement in language and grammar. Also, the speed and timing of delivery plays a big role, because if both parts in the communication aren't how can we say it, aren't in synchronization, uh, they won't understand, and maybe if timing is not the same in both parts, communication will be affected. And also confirmation of acknowledged requirements is necessary. This means that the communication will happen. I'm talking about the requirements for computer communication. Uh, they also need to have a message encoding, message formatting and encapsulation, message size, message timing, and message delivery options. As we can view here, it's mm, barely different from human communication, but it's the same, it's communication. But we are going to talk more about the requirements. Well, first there's the message encoding, and this is a process of converting the information that you see into another form that is an acceptable form to be sent or transmitted through the media you're sending it. And the other part should decode your encoded information for it to understand what the source wanted to say, wanted to transmit, well, communicate. Well, the message formatting and encapsulation is the way the message. Oh, sorry, there was a problem. Okay. The message formatting and encapsulation is the way the message should be sent. The format of a letter is a good example. It has a sender, it has a receiver, it has a salute, it has the message, and the goodbye. In computer there's also rules. For example, at first of the message there is a frame of the address that sent it, and the address of the new host that will receive the message. There is also another part in the message that is a flag, start flag, that says that the message starts at this point, and the identifier of the recipient, the one who receives it, the identifier of the sender, the bits, the data converted into bits, and something that says that the message is done, and that's where it ends. You know, there's also the message size. You cannot send a too long piece of information if the sender doesn't, or the one who receives it doesn't admit it. Maybe you should make all your data that you want to send into tiny pieces that are called segments. And when those segments arrive to the destination, the receiver hosts put all the pieces together again, and it decodes it, and you can see the information. There are some message delivery options. The first is unicasting. That is when the source of the information wants to send just to one receiver. The multicasting is when the source wants to send to more than one receiver, but not all the hosts. If you want to send to all the hosts, it's called broadcasting, and everyone in the network can see it. There is the message timing. In the message timing, there are three parts. The first is the access method. The In the communication, there should be something that says when you can start communicating and how to respond if you cannot start communicating. There is also flow control. The flow control is to moderate, in the communication, maybe the speed of the message that is being sent. You cannot go too fast, you can't go too slow. So the flow should be in the correct balance. You should be alert when you are going too fast or too slow. And the response timeout. And the response timeout is when you are asking for something, you should have a response. If you don't have a response, you should follow a protocol. If communication cannot be possible, but you should always have some response from the receiver. For communication to be possible between devices, there should be protocols. Protocols are like some rules that devices should follow. They want an accurate and complete communication. There can be protocol sheets that are some interrelated protocols that work together to bring the communication to both sides of the sender and the receiver. Some examples of protocols maybe is the hypertext transfer protocol. This governs the way the server and the web client interact. The internet is filled with HTTP, the web pages and all of that. There is also the TCP, that's the Transfer Protocol Transmission Control Protocol. This converts or segments the message between the web server and the web client. And here's where the Internet Protocol arrives and takes these segment messages, converts them into packets, and sends them through Internet. And it shows the best path from the sender to the receiver. There's also the network access protocols. As an example, there's the Ethernet, but it's just the way communications happens through the media. It's converting all this information into signals that can be sent and received. The protocol suites and industry standards. Protocol suite is a set of protocols that work together. For example, in the first column we have the TCP/IP protocol, which is the Internet Protocol. Here we have the IP, the TCP, the HTTP, the DHCP are all part of this suite of the Internet Protocol. All these little protocols are play a big role in the Internet communication. Standard Protocol is a protocol that has been approved by many organizations. This ensures that components from different vendors or organizations, brands, can communicate between and operate between them. There also are proprietary protocols, which means that they have an owner. This can be an organization or whatever, but you can only use it if you have the permission from the vendor or the creator, and you cannot modify it. That's the case of AppleTag, which is the one before the last column. and novel protocol, which is the last column. The TCP/IP protocol and communication process. The IP suite contains the protocols that the Internet uses to send and receive info. It is now formally known as TCP/IP because those were the first protocols that composed it. But as it has evolved, other protocols have been added to it as HTTP or DHCP or Ethernet, maybe. This started since 1969 when the first packet was sent, well, obviously in the United States, and it is continuously evolving nowadays. Here we can see the communication process of an HTML web page. You have the data that is going to be sent. You add the HTTP protocol that is to be understood on the other side. Then there's an IP assigned to it. For source, that's the one that sends it, and the destination that will be receiving it. Ethernet, everything goes through the Ethernet, and through all the media and intermediary devices that can be hosted. Each process in that packet is processed to see how the information should be arriving and from where, and then it goes to the client and you can view that web page. Talking about standard organizations, these are the ones that are in charge of making a product accessible to everyone. With that I mean that when you go to store to buy something, maybe a router, there are many different choices because they can communicate with the same protocols. For example, to maintain the open internet with freely accessible specifications and protocols, there are some organizations that helps this process. There's the Internet Society that promotes the development of the protocols of the Internet. There's the Internet Architecture Board with 13 members that provides oversight of all the protocols and procedures in the Internet. The Internet Engineering Task Force, the IETF, this constantly update and maintain Internet and TCP/IP technologies. There is the Institute of Electrical and Electronic Engineers, the famous IEEE. This is dedicated to advancing technological innovation and creating standards in telecom and healthcare. And the International Organization for Standardization, ISO, so famous. This creates standards for routing protocols. There are some reference models. We can say that TCP/IP versus OSI. Okay. There are two basic types of networking models: the protocol and the reference. On one side, we have the protocol model that matches particular protocol suites. It is hierarchical. It describes the functions that occur at each layer of protocols. In here we can have the TCP/IP model with all these characteristics. The reference model is consistency within all types of network protocols. It has aiding clear understanding of the functions and processes involved. And here it is the OSI model. Here we have both of the protocols. One is the models. One is the OSI model. The first layer is the application. which provides the end-to-end connectivity for humans to communicate in the network. It's the information, as you can see. The presentation layer provides common representation of the data transfer between application layer service. This session provides services to the upper layer, which is the presentation, for organizing and managing data. Transport defined services as will segment, transfer, and resemble info between devices. Network the service to exchange the pieces of data over the network. Data link methods for exchanging data frames. And physical is the mechanical, the physical things like for electrical, functional, and procedural means to activate, maintain, and deactivate physical connections. On the other hand, we have the TCP/IP model. First protocol is the application, which is the same as the OSI model, represents data to the user, but it also encodes dialog control as a presentation. Transport support communication between diverse devices across the network. The internet calculates the best path in the network to the route. And network access. It just controls all the devices in the network. Oh, sorry. Data encapsulation is necessary because you cannot send the whole information at the same time. Because if other devices want to communicate, they should wait till all the video or all the photograph or all the document has been sent, and that takes a lot of time, so other communications can get to the network until the same receiver maybe, and this application data passes down the protocol stack on its way to be transmitted across the network media. Various protocols add information to each level. The form that a piece of data takes at any layer is called a protocol data unit. Okay, in this process, for example, the data, this is the general term that is used in the application layer. The segment is in the transport layer, the packet in the network layer, the frame is the data link layer, and the bit are the physical layer that the protocol data unit uses when the physical transmit data over the network. Well, with this is chapter 3, most relevant information. Thanks for watching.